Here we would like to explain about the real-time traffic monitoring and management system for the campus network of UMKC. So basically the campus network consists of different kinds of data such as net flow, VLAN, etc. So our goal is to propose a management and monitoring system such that the traffic is visualized and the network administrator is able to understand what is exactly happening in the network in a real-time manner, and it also pinpoints to any special issues happening in the network. So these are the couple of related work we would like to mention. Lambda architecture, Cerner, Netflix, Twitter, who inspired us to create this architecture. So our motivation is two main motivation. One is to tell the most bandwidth usage in the 5 minutes interval in real time, and second one is to process the history data of the bandwidth usage and show a summary of it. So our network UMKC network architecture is a three-layer design: access, distribution, and core. So this is a basic architecture which we will actually be accessing, which will give us the network data. So as I spoke before, these are the different kinds of data we will be using. So basically we have 4 different kind of switches and 3 different kinds of data: network configuration data, the VLAN data, virtual machine, and the knowledge base. So this is the data sample available on the screen. So our proposed architecture consists of 4 major components: data warehouse, the real-time event processing, data batch process, and data visualization interface. So this architecture explains that the network explains two aspects: the real-time processing and the batch processing. So the network data collector sends the data to different topics in the Kafka, and these Kafka topics are retrieved from the storm processing to get the results using different storm topologies. This is the real-time event processing. The Hadoop batch processing takes the network data, so stores into HBase and retrieves it to the visualization interface. So these two batch processing also involves different aspects such as anomaly detection and as well as different storm topologies for the top end algorithm. So in detail about what coding happens in batch processing, the mapper part, we input the net flow data and analyze what is the IP address and the bandwidth usage and retrieve only those two criteria or parameters. And the reducer part actually finds the top most usage of bandwidth, returns those IP addresses. So in the real-time processing, we have different kinds of topologies using different kinds of groupings. So basically the spout would be the Kafka. As I previously mentioned, different kinds of topics will give out the network data, and these are retrieved and processed for parameter retrieval and then given to the different bolts such as top and bandwidth flows, top and duration flow, or an DOS detection or an anomaly detection. So coming into focus about anomaly detection, we are focusing on 2 different pairs of data. One is the source IP and destination IP address, and another one is source IP and the destination port number, and the destination IP and the source port number. These 4 are the major categories of DOS attacks happening on the network. So we identify these data and also find the accuracy for the same. So the results, the preliminary results, what we got from this system are as follows. The system setup is, we have one four different kinds of systems, which handles Hadoop and Storm. So we have the Hadoop name node and three different data nodes, and one Storm Nimbus and three different supervisors. And there is one other system specifically assigned for the Zookeeper to handle all these four systems. So the batch processing, we have a dynamic table which sorts and gives us the output of different kinds of data based on the time. So for the top end bandwidth for the real-time processing, we have this visualization through Python, which shows the top three bandwidths in the span of 5 minutes, from 5 minutes data for every 10 seconds. So top and duration is also being shown, the top three durations in this in from 5 minutes data with difference of every 10 seconds. So the real-time anomaly detection has, as I previously mentioned, four different kinds of categories, such as the source IP, source post, destination IP, and destination port. So correctness evaluation. This gives us the accuracy about using Weka, the machine learning algorithms, different kind of machine learning algorithms. From the analysis of all these data, we found out that for the source IP and destination IP, using support vector machine would give us the highest percentage, and for source I port and destination port, naive Bayes would give the best results. So data visualization, we have a web servers installed for visualization of data. So this is the screenshot of the same, and we also have a mobile app, an Apple mobile app, which visualizes the data as in. So this is the Storm topology which is being submitted in the system. So our conclusion is that due due this phase of our project during the phase of our project, we have been utilized the state-of-art real-time process technologies such as Apache Storm, Kafka, and implemented data visualization web server. We have also obtained a preliminary result of the goal, and we have a depth understanding about Weka machine learning works, how it works with Storm and Kafka, and we also expect to work more and actually implement in a real-time manner. This project is done in a partial credit of the real-time big data analytics course from the CSW Department of University of Missouri, Kansas City. So we would also like to show the demo of the Storm topology. So here we have a Kafka port and six different topologies submitted. So there are, as previously mentioned, the DOS destination bolt is the anomaly detection bolt, and the other five bolts are the top end algorithm bolts. So, and this is the web server we have uh, established, which shows the preliminary results such as the visualization what we showed previously. So we also would like to show you the iPhone app, which which shows the preliminary result, so which can be also be implemented. We are also planning to extend all these data into an real-time streaming and notification app. Thank you very much.